Hello everyone. Today we're going to talk about recursive sequences in dealing with sequences and series. So if something is recursive, that means that I'm repeating. I am taking the definition or the rule that we're using, this function, and I'm changing my end value each time, and I'm plugging it in, and I'm just repeating what I'm doing. So I'm recursive in my actions. So a recursive sequence. Given a term, or the first few terms, and a function defining the sequence, determine the terms in question. So our example says find the first four terms of the recursively defined sequence. Well, there is determine the terms in question, find the first four terms. So find the first four terms. So that's that part, determine the terms in question of the recursively defined sequence. Well, there is my function defining the sequence. That is this right here. That's my function defining the sequence. And I was given a term. There's my term, my first term, a sub 1. So I can use this information to be able to find my other terms. The first thing I want to show you is that whenever I say n equals 0, now earlier videos, our values are for n are 1, 2, 3, and 4. Well, it's changed up here because this is now n plus 1. In order to get n or a sub 1, in order to get a sub 1, I'm going to look at n equals 0. And that gives me my first term because no matter what I can move back one. Instead of starting at n equals 1, I can start at n equals 0 because in my recursively defined sequence, I have a to the or a sub n plus 1. I can start one number back. So whenever I say n equals 0, what that gives me is a sub 1, which we already have defined as 4. And you're going to see how this plays a role. So whenever I said n equals 0, I plug in my 0 for n, and I have a sub 0 plus 1, which gives me a sub 1, which equals 4. And that first term that we get, they gave it to us, but showing you how we could how it works in order is going to be fundamental. Because then whenever I say, okay, let n equal 1, I say, well, that is a to the 1 plus 1, so a to the 1 plus 1 equals 1 plus 1 over a sub 1. Well, my a sub 1, I've already calculated that, or I was already given that. And what that's going to equal is a sub 2. And a sub 2 equals 1 plus 1 over 4. That's where my 4 came from. Remember, it was a sub 1. And see, all of this right here, everything that I have where I say let n equal 1, all of this is based off my value up here. All of it is based off of that. The term prior. And the very first term in that was 4. That's how I was able to find this value, 5/4. Therefore, a sub 2 equals 5/4. And I did that by using a sub 1 in the formula for a sub 2. So a sub 2 equals 1 plus 1 over a sub 1, which is 4. So 1 plus 1/4 equals 5/4. Therefore, a sub 2 equals 5/4. Let's look at it whenever I say n equals 2. Well, hopefully you understand just by saying this, all my work here is going to be based off of what I got for this answer. I'm going to have 5/4 in this one. So a to the 2 plus 1, which is a sub 3. A sub 3 equals 1 plus 1 over a sub 2. And how did I get that a sub 2? Well, see, it's a sub n. What did I say? N is 2, so I plug in my 2. Therefore, a sub 3 equals 1 plus 1 over 5/4, which equals 9/4, or 9/5. Therefore, a sub 3 equals 9/5. Again, notice there's my 5/4. This is a sub 2. A sub 2. These two values right here came from my prior calculation. And the same can be said down here. I'm going to end up with a sub 3 in my equation to calculate a sub 4. A sub 4 equals 1 plus 1 over 9/5, which equals 14/9. Therefore, a sub 4 equals 14/9. It is only tricky, really, with just not being comfortable and familiar with it. Once you get more comfortable with it, then a lot of that trickiness goes away. So, the way to get unfamiliar with it, or at least for me, is to jump into doing an example. So what I would like for you with this example is to pause the video and then you work it. And then what we can say here with this one is that you can start off and say let n equal 0, but whenever you let it equal 0, you're going to get the first term. So we know the first term. I'll help you out even more. So we know that a sub 1 is there. So really you just need to find 3 other terms because it asks you to find the first 4 terms. And with this is where this was n equals 0. So what you need to do, and I'll help you with this, n equals 1, n equals 2, n equals 3. Alright, you try it, let's see if we get the same answer. Alright, so n equals 1. That means I'm going to replace everywhere there's an n with the value of 1. So this turns into a sub 2. So a sub 2 equals a negative 1. And see, there's an n, so I'm going to put a 1 there. Times, and this is a to the first, right? N is 1. A to the first. What is a to the, or a sub 1, sorry. A sub n. N has the value of 1, so therefore I replace it. And how about I just write it here? A sub 1, right? Which is the numeric value of 6,561. Well, this is a negative 1. Negative 1 to the first power is a negative 1. And this number here is the square root of 6,561, which is 81. So I have a negative 81. That's the first one. I do the same again. I'm going to take n equals 2. Everywhere there is an n in my function, I'm going to replace it with the number 2. So this becomes a to the third, not third, a sub 3. I don't know what's wrong with me today with that. A sub 3 equals, that's a negative 1 squared, because remember I'm using n equals 2, so n equals 2 squared, and this becomes a sub 2, which equals a negative 1 squared, which is a positive 1, and a negative 81. I've got a negative under the radical. Negative under the radical. So that becomes 1, so we don't have to worry about what this can be viewed as, remember, is 81 times a negative 1, which equals, and well, I'll go ahead and write this. I equals the square root of a negative 1, so that turns into 9i. And the next one, n equals 3, so everywhere there's an n, I replace it with the number 3. So it becomes a to sub 4, a sub 4 equals a negative 1 cubed, remember because n equals 3, times a sub 3, and we found out that that was 9i. So that's a negative. A negative 1 to the third power is a negative, and 9i simply gives me a negative 3, and that I just has to remain under the radical. So a negative 3 square root of I. And please notice that each time, starting up here with my first term, it was taken and plugged in. And then my second term was plugged into the following. And my third term, all the way back around, was plugged in. Recursive. Okay, guys. Critically think, structure your homework, watch the publisher's videos, and good luck on your homework.